James, we're back again and in the boardroom of IMPARTA. Thanks for having me.
Thank you for having me, Tony.
I think we've run through quite a bit actually, and the soil that we spoke about recently, albeit you wanted to do a few more additions, is an important topic. But one of the other important topics, which sometimes might even relate to the soil, would be rising damp, salt damp, other forms of dampness.
Yep.
That you might be engaged to address or work out what the cause is.
Yep.
What can you tell us?
Look, Tony, there's various forms of damp, as you've alluded to. They're commonly referred to as rising damp or salt damp, slab edge dampness, falling damp. But basically, they all refer to, I guess, the unwanted effects of moisture coming into contact with the building fabric.
Yep.
So the sorts of things that you might see is like salt damp, which is the classic one, mostly for Adelaide, because we've got some salt in our soils, is sort of fretting of mortar at low levels on your building, or I guess deterioration of brickwork or stonework on your building. That's generally caused by either something called slab edge dampness or rising damp.
Mm-hmm.
It's generally a problem related to inadequate damp proofing of your footing or of the building. So basically what happens is moisture gets absorbed into the building or into the footing. Much to a lot of people's surprise, concrete and bricks are not waterproof. They're not fully impervious. Actually, they comprise basically a matrix of tiny capillaries. And it's these capillaries which actually draw the moisture in and create a suction force. It's an incredible process, and it's basically unstoppable unless you create an impervious barrier in between the moisture source and the thing that's trying to attract the moisture.
And this is why it's so important to get that moisture away from the building, take the water away, whether it be pipes or fall of the land.
That's right. So look, our number one, as we say to people, our number one defence is to get the water away from the building. If you keep the water away, that gives you a greater chance of water never coming in contact with the building. So even then, if your damp proofing is not great or there's an issue with it, at least that source of moisture has been kept away.
And of course, some of the older buildings as well, particularly some of the older strata style buildings, the level of damp course or moisture preventative measures just weren't part of the same.
Like with all things to do with buildings, we discover things as they come to light. So damp proofing improved over time as engineers and building professionals and the government, I guess, learnt more and understood more about what was causing these issues. Yeah, sure.
And I know we're going probably onto a little bit of a tangent here, but what just popped into my head when we're talking about taking water away from the building and getting it off the site, again with some of these older buildings, older, particularly the larger size, strata blocks, you'll find what I hear a lot is that the getting the water away isn't as easy as it used to be. As in, over time, there's been a development of we've got larger amounts of water falling on buildings. Gutters aren't built to the 50 years ago. The size of the guttering is not what it is now.
That's right. Yep. And I suppose one thing to keep in mind is if you're expanding your impervious footprint on your block. So if you're building bigger car parks or building another roof covering to perhaps cover those car parks or something like that. The golas, things like that. Things where there wasn't an impervious surface before, you're actually increasing the permeability of the site, which means you'll have more stormwater runoff.
More to get rid of.
And if you don't, I guess every stormwater system's got a certain capacity. And as soon as you start increasing the impervious area of your site, you're going to start reaching closer and closer to the capacity of that infrastructure. So you might need to look at actually making that infrastructure bigger, which is something that a civil engineer can help you assess. If you're doing something like making a bigger car park, you should really be engaging a civil engineer anyway, and they'll make that assessment for you.
Sure. And that could also involve an increased pump size or something like that if water's flowing to the wrong side of the site.
Definitely. Pumps are a classic because they definitely do have a limit, a capacity,
Yep.
and they are only designed to pump out a certain rate of water at a certain time.
And a life expectancy.
And they've got a life expectancy as well.
Yeah.
Yes, that's right. So there's, and they should have redundancy in case there's a power outage or something like that. So there's a whole bunch of things to consider.
Lovely. Thanks, mate. Really appreciate it. You've been wonderful.
Thanks, Tony. Cheers.
Thanks, James.